Hello, how are you? How are you doing? My colleagues, my teachers, my professors, how are you doing? It's me, the Professor Mourad Sultan Ezouidi, is now with you to explain his theory. Okay, so now it's 36 past 8. So Professor Mourad Sultan Ezouidi will explain to you today how can you solve 11 degree from the equation. Okay, when let's say Abel's theorem closed the door. Mr. Mourad Sultan Ezouidi opened the door, okay, and built the bridge for you. So today we have the honor sorry, today we have the honor to explore a groundbreaking advancement in the field of algebra, presented by me, the Professor Mourad Sultan Ezouidi, a mathematician whose deep research into polynomial equation has led to powerful new method of solution. Okay, so prepare yourself. Contrary to the classical conclusion of the Bell theory, which state that uh, there is no general solution by radical, but we, Professor Mourad Sultan Ezouidi, let's say solve polynomial to the power 11 to the power 18, where the roots are radical. Okay, we'll show this example for you just when starting. So prepare your sheets, your papers, prepare papers and pens and your scientific calculator, and we'll start with the Professor Mourad Sultan Ezouidi to solve this 11 degree from the equation. So we told that contrary to the classical conclusion of the Bell theory, which stated that there is no general solution by radical for polynomials of degree 5 or higher. Professor Ezouidi introduced a novel theoretical framework that allows the exact solution of specific high-degree polynomial equation, introducing those of degree 11 and beyond. Using what's known as a Ezouidi theorem, we approach the following 11-degree polynomial equation, which is x raised to the power 11 minus 33x raised to the power 10 plus 495x raised to the power 9 minus 4455x raised to the power 8 plus 26,730x raised to the power 7 minus 112 66 plus 300, of course, multiplied by x to the power 6 plus 336,798 x to the power 5 minus minus uh, minus 721,710 x to the power 10 plus 1,082,565 x cubed minus 1,082,565 x squared plus 649,539 439 I imaginary complex number times x plus 100 uh, plus 1,771,470 minus 649,539 I equal 0. So here, my professors, my colleagues, in this example, if we are going to dive into the structure of the theorem of the Professor Mourad Sultan Ezouidi, we will see that it's a powerful method. It will build for you, let's say, a story in mathematics, okay, in mathematics. As we are a mathematician, we should, let's say, help you. How can you use Ezouidi theorem to solve 11-degree polynomial equation? Unlike traditional methods that rely on approximation, numerical iteration, or claim and possibility, Ezouidi method provides a systematic and exact decomposition of such equations. Here again, it's the Professor Mourad Sultan Ezouidi. Welcome everyone to this special session. Today, you are not just solving an equation, you are challenging mathematical history itself. According to Abel theorem, general solution general solutions for 5-degree and higher polynomials are impossible using radical. The door was closed. Mathematician, Mathematicians stopped researching. But Professor Mourad Sultan Ezouidi says otherwise. Professor Mourad Sultan Ezouidi says otherwise. Okay? Thought, or sorry, Professor Mourad Sultan Ezouidi says otherwise. Through the power of Ezouidi theory, a new path is revealed, one that leads us beyond classical limits into the exact algebraic solution of 11-degree polynomial equation. So here I'm going to explain for you how can you apply the Ezouidi theorem, and you will understand how the method it works. Okay, so let's start. Okay, uh, we can say that. Now let me guide you through the lens of Ezouidi theorem, where structure and symmetry lead the way. This is in fact is not trial or error. This is systemic. This is exact, and this is reproducible. We are not relying on numerical roots. We are pulling the exact algebraic roots from the very fabric of the polynomial equation. Okay, so now I'm going to share the link, to share the example how we are going to solve. Okay, as I did before. Okay, so this is our equation. I think you can see. Okay, let's see. Okay, so this is the example, my kids, my professors. You can see now the example in front of you. This one, and okay, you can see this is the example. P of x, it's an 11-degree problem equation. You will try to solve this polynomial to the power 11 using the discriminant formula of Mourad Sultan Ezouidi. So you can see that the coefficients are as the following. L9 is going to be 649,000 1,539i imaginary, and L10 is equal to 1,771,470 plus 649,539 I. I, this is imaginary complex number. Okay, here, my kids, in this example, before there is a previous example, we calculated s minus 1, s1, s0, s1, s2, s3, s4, s5, and S6, S7, S8, S9, and S10. Okay? And we found that S1 is equal to 0, S0 is equal to 0, S2 is equal to 0, S3 also up to S9, which is different to 0. Okay. Now we continue here in this example. Is another example, coefficient, different coefficient. Okay, we calculated here, we use, let's say, the Ezouidi theorem. We use Mourad Sultan Ezouidi theorem, putting k equal 1 to find s minus 1, which is by convention is always equal to 1. We continue here, okay? We continue here, my professors. Now let me guide you through the lens of Ezouidi theorem, where the structure or where structure and symmetry lead the way. This is in fact is not trial or and is not error. Okay, this is systematic. Systematic. This is also an exact method that will lead you to find the exact roots of this 11-degree polynomial equation. Okay, you can see the coefficient of this polynomial to the power 11. Okay, this one, these are the coefficients of my 11-degree polynomial equation. I calculate s minus 1, which is equal to 1. Then we should calculate s0. Okay, we calculate s0 is equal to 1. Here we use the Ezouidi theorem. Okay, here my professors, we are not relying on numeric roots. Okay, we are pulling the exact algebraic roots from the very fabric of the polynomial. Okay, notes. Notes how classical algebra holds here. Okay, no one can solve this unit to the power 11. Okay, no one can without using Mourad. Okay, so we can say that notes how classical algebra holds here. Okay, stop here. Stop here. Don't stop. Okay, okay, find here. Okay, stop here. So we told that the classical roads end with, let's say, Abel's barrier, but I've built new bridge for you, and I will walk you across it now, my professors. So, in order to solve this problem to the power 11, you should first of all calculate calculate the coefficient of the new 11-degree polynomial equation that corresponds to the original 11-degree polynomial equation. It means you are going to calculate s subscript k minus 1 equal to 2, where k ranges from 0 to n minus 1. The n is going to be 11. 11 minus 1 is 10, means they are going to find s minus 1, s0, s1, s2, s3, s4, s5, s6, s7, s8, s9, and s10. Okay. So here in this example, my kids, all the s subscript k minus 1 are equal to 0 except s9. Okay? We can use it. You can use your calculator and you'll find that the value of s subscript k minus 1 are all 0 except s1. Okay, let's dive into the structure of this theorem and put k equal to. Okay, so you can see that every term sticks in this formula. Every coefficient of the 11-degree polynomial equation has a message, and the Ezouidi method knows how to listen. The Ezouidi method knows how to listen. Okay, here. Okay, okay. We continue. We told that uh, Ezouidi method, the method of Ezouidi knows how to listen. What seems impossible before or what seems impossible by tradition becomes here clear and exact with this method. So if you are going to dive in the structure and putting k equal 3, you will obtain S2 equal as that. Combination to choose 1 times n choose 3, L0 cubed minus n minus 2 choose 1 times n squared times L0 times L1 plus n cubed times n. Now, my kids, you are going to calculate the value of S2. You will find that S2 is equal to 0. Okay, we continue. Watch closely, and you will see at the end that the roots will emerge one by one. Each step perfectly specified. Okay, let's do it. Let's do it, my professors, my learners, my colleagues. Here is a chance for you to understand what is okay. I'll just a moment. I'll come. Okay, that is here. Close this one. No need. Don't save. Okay. I'm here. I'm coming. Just a moment. I'm share now. I will share this. Okay. Mm-hmm. Good man. So we told that if you are going to dive into this structure, you will see that each coefficient of the original 11 degree from equation send you a message to what? To the 11 degree formula equation. That is new, and you should find its coefficients. Okay, so we can see that now S2 is equal to a no, to 0. We continue and we dive into the structure when k equal 4 to find S3. Okay, to find S3, we will see that in fact S3 is equal to 0. Okay. And even this equation, if you are going to give to the ChatGPT or DeepSeek or Microsoft Math Solver, you can do. Okay, if you want to give this to Math to Microsoft, no, in front of you, it will tell you there is no solution. Okay, I will try to do it. Okay, I will try to do this. Stop here. Okay, I will do it after, no problem. So we told the S4. This is the formula S4. When dive into the structure or the theorem of Mourad Sultan Ezouidi, you'll see that S4 is equal to 0. Move now and set k equals 6, okay, where in the Ezouidi theorem, you find that S6 is equal, S5, sorry, put k equal 6 to find S5. Okay, when putting k equals 6, you will find S5 in terms of combination and the coefficient of your original derivative equation. And this coefficient, S5, will give you the sixth coefficient of your new derivative equation. That corresponds to the original derivative equation. Okay? I will tell to my friend. Okay. Hello, Mr. I'll see this first. Hello, Habib. How are you doing? You're a mathematics teacher, pioneer, the Professor Mourad Sultan Ezouidi now in talking. Okay, I'm going to tell you, try to keep watching the lecture, okay? That will be benefit. Okay, thank you. Goodbye. Okay, we continue with all that after diving into this structure and after seeing that each coefficient, in fact, let's say uh, its coefficient uh, has a message, and you can see the method of Ezouidi knows how to listen. You will see that what seems before impossible by tradition becomes now clear, okay, and exact with my method. Okay, now we calculate my professors. We calculated, let's say, as 5, we will say that the value of S5 is a no, means is a zero. Now, let's dive again into the theorem. Let's see the theorem again and replace k with 7. Okay, to obtain the seventh coefficient. So, we make our expansion and we expand the formula and we wrote it in its lowest term and we found that 6 equal as below. You see this form. Now, what is needed exactly? Just go and make your substitution and make your calculation. After making substitution, my professors, you will find that S6 is equal to 0. Okay, we continue. Watch closely, and you will see that the roots will emerge one by one. Each step perfectly justified. Okay, each step perfectly justified. Justify or the equation, the roots, let's say satisfy the equation. Okay, means that all the roots are correct. Means that here in this example we solve 11 degree from equation with radical, with radical. Okay, contrary example to Abel theorem. Okay, now put k equal 8. After putting k equal 8 in this uh, theorem, we'll obtain a 7 is equal to that. This is the formula to get a 7. The coefficient of 7 is given by this formula. This formula is available, is generalized for any n degree polynomial equation. Okay, clear? Okay, okay. So we can see that as as 7 is in fact is equal to 0. Okay, make your own change and substitution with the coefficient of the ordinary level degree from equation in this formula. Okay, but we give you the value of the seventh, the value of the eighth coefficient of this 11 degree from equation, and obtain that is going to be equal to a. Okay, we continue. We continue, let's say, explaining. Professor Mourad Sultan Ezouidi explains how we get exact roots, with how we solve 11 degree from equation with radical, with radical. Okay, let's. Okay, so we told that S8, just put K equal 9 in the theorem and make your substitution. Okay, stop here. Okay, this is the value of, this is the formula that will give you S8, meaning the ninth coefficient of the new 11 degree from equation. We'll make our calculation, my professors, colleagues, teachers, and we found that it's going to be equal to an error, to 0. It means to 0. We proceed, we continue in order to find the S9, just put, let's say put K equal 10 in the formula and go down and calculate the value of S9. So S9 here is different to 0. Okay, it's written in terms of complex number. Okay, times 11 raised to the power. Let's see how it works. Okay, just calculation. The coefficients are in front of you. Okay, and the roots will see one by one how the roots emerge. Okay, how the roots emerge one by one. Okay, let's see. Okay, so we told that after, let's say, continuing finding S9 and S10, you will see that here it is not guessing, not approximating, but exact and okay, and you will see that if you watch closely, you will see that roots will emerge one by one. Okay, each step perfectly justified. So here we calculate S9, we obtain that S9 is equal to 649,529 multiplied by minus 1 plus r times 11 raised to the power. Okay, so you can use the calculator and figure out the value of S9, you find that is equal to that. Okay, where N9 is 649,559 multiplied by 5. And L10 equals 1,000,000 negative 1,771,470 plus 649,539 are right. So here, as we found S9, we need to find also S10. To find S10, let's dive into the structure, and you can see that in fact every term sticks, every coefficient is a message. When the coefficient of L, for example, S8 is equal to 0, has a message for you. S7 equals 0 has a message for you. S6 equals 0 has a message. Okay, has a message for you. Okay, S4 equals 0 has a message for you. S4, S5 are equal to 0. They have or they are giving you a message. Okay, which kind of message you should understand? Okay, so here this is the formula how to find S10. Okay, just dive into the structure or the theorem of Mourad Sultan Ezouidi and put K equal 11. Make your expansion, write in its lowest term, and you will follow the steps that Professor Mourad Sultan Ezouidi explained, and he is now explaining to you. This is not just about one equation. It's about a formula. It's about a theorem that I, let's say, depend, let's say, or relate that I depend more than 14 years of work. Okay? It's not easy. It's not easy. For any mathematician who want to understand, he has to apply the theory and practice more and more. Then he can ask how. And the proofs that I made in my books that I published, okay, are now available for you. You can buy the book, okay, to understand. Okay, now with all that, I'm going to calculate S10. So it's easy, just calculation, and we'll obtain that the value of S10 is going to be equal to 0. So S10 is going to be equal to 0, meaning this coefficient, the 11 coefficient, has a message. We'll give you a message. Okay, which kind of message you should, let's say, receive and understand? Okay, this is the question. So we continue with all that as 10 equal to 0. So here we can conclude that all the coefficients of my new 11-degree polynomial equation are equal to 0 except S9, which is equal to, we call, okay, coming up, okay, here, stop here. Okay. So we told that, here my kids, we told that S10 in fact is equal to, no, equal to 0. You can use the calculator. You will apply this formula, S10, make a replacement. Okay, you replace L0, L1, L2, L3 up to L10 with their values. Will end with 11. Okay, and you will try that. You will find that you will find yes, SN equal to 0. Okay, you can use the calculator. Okay, so here you can see in other words, S0 equals 0. Means that this is not just about one equation at all. This is about changing how we understand algebra itself and how we understand how we master the solution of nth degree polynomial equation. So here, my theorem or Ezouidi theorem writes what was believed to be a dead end. We bring light into what was once a shadow. This method is not only powerful, it's a new chapter in the story of mathematics. It's a new chapter in the story of the field of mastering of the solution of nth degree polynomial equation and mastering the solution of nth degree linear equation. Okay? Here, we told that S0 is equal to 0, S1, S2, S3, S4, S5, S6, S7, S8, S10. All of these, let's say, have a message, okay? To master the solution of an integration equation. Have a message, and we should receive the message. Okay, so I'm going to write my new polynomial to the power 11 as that. P of x equal x raised to the power 11 minus s0 for the x raised to the power 10 plus s1 for the x raised to the power 9 minus s2 for the x raised to the power 8 plus s3 for the x raised to the power 7 minus s4 for the x raised to the power 6 plus s5 for the x cube raised to the power 5 minus s6 for the x raised to the power 4 plus s7 for the x raised to the power 3 minus s8 for the x squared plus s9 for the x minus s10 for the r. Okay, so these are the coefficients that that had been derived from the Ezouidi theorem. Professor Mourad Sultan Ezouidi explained that P of x has to be written like that corresponds to the original integration equation. Okay, so here and so one by one, the exact roots of 11-degree equation stands before us, meaning that the solution will be clear if we reach this step. Wherever cell or wall, we have carved a doorway. This is this this is a proof. Not that Abel was wrong, no, but that there is a more beyond the boundary he described it, meaning that there is more beyond the boundary he described. Zwicky theorem here doesn't break the rules. It reveals the deep structure behind them. Okay? So, if we continue, we see that P of x, P of x is equal to x raised to the power 11 minus s9 to the power r times x equals 0. Here it's clear that x is going to be 0. Or x raised to the power 10 plus 649, 539 multiplied by, in parentheses, minus 1 plus r times 11 raised to the power 10 equals 0. So I'm going to transfer this value to complex number on the right hand side. So it will transport with a negative sign. And this negative sign I will write as exponential I pi. Okay? Then, and I should multiply this by exponential 2k I pi. Means it will be 2k plus 1 I pi. Then if I'm going to solve, to find x subscript k, I should divide this term by 1 over 10. Look here. So you can see that because x raised to the power 10 equal negative 649,539 multiplied by minus 1 plus I exponential minus 1 plus I multiplied by 10 raised to the power 11 raised to the power 10. Now I'm going to find what? To find x subscript k, I should divide all of this by 1 over 10. So the same it will be here. Here it will be 649,539 multiplied by, between parentheses, negative 1 plus I multiplied by 11 raised to the power 10. You see 11 raised to the power 10, all 1 over 10, it will be 11. I will write it here. And the rest, it will remain, it will be the same next time. So it will be 11 by 649,539 multiplied by minus 1 plus I, all raised to the power 1 over 10, minus exponential to k plus 1 I pi over 10. You can see here, let's say the roots will merge. You can see here, not, let's say, guessed, not approximated, okay, but exact algebraically. We are not rounding here, my professors or colleagues or learners. We are evening. So we can see that the roots will emerge one by one. Okay. So, and you will see that how wonderful this step. Okay. So now these are called x roots. These one, x equals 0, or x subscript equal 11 times 649,539 in parentheses, negative 1 plus I, all to the power 1 over 10 times exponential to k plus 1 I pi over 10. All of this is called x roots of my 11, new 11 degree from equation. Okay, this one, this is the roots. So, in order to find now the exact roots, these are the exact roots of this polynomial that is written in terms of the sum from 0 to n. Okay, s subscript k minus 1 multiplied by minus 1 to the power k x n minus k. Receive the new 11 degree from equation relative to the original 11 degree from equation. These are the exact roots. Okay, you can see the roots in fact merge one by one. Okay, now to find now the roots of the original 11 degree from equation, the roots has to be written as that alpha subscript k from 0 to 9. It will be L0 plus and the x roots of my new 11 degree from equation that I obtained here. So it will be 33, okay, plus 11 multiplied by 649,539 multiplied by minus 1 plus I, all raised to the power 1 over 10 times exponential to k plus 1 I pi divided by 10. Okay, all divided by 11. You can note that 33 divided by 11 is 2. 11 divided by 11 is 1. So the last answer, my kids, has to be equal to, this is the exact roots of the original 11 degree from equation, this one. 3 plus 649,539 in parentheses, into 1 plus I. So the parentheses raised to the power 1 over 10 times exponential to k plus 1 I pi over 10. And the 11th root is that because x equals 0. Okay, to be L0 plus x 11 divided by 11. L0 is 33. X0, x11 is going to be 0. So it will be 33 plus 0 is 33. Divided by 11 is going to be equal to 2. This is how to be solved this 11 degree from equation where the coefficient are are uh, saying or giving you a message. Okay, because it's coefficient. Every coefficient has a message. Now let's take the example, and we'll do this in Microsoft. And Microsoft will stop solving. I will tell it's not an equation. It's difficult. Okay, let's see. Okay, okay. So I will take now this one, if it's possible. I'll take the equation. I will see if wait, I think I have just a minute. Okay. No. So thank you for listening. Thank you for joining. And this is Mourad Sultan Ezouidi. Okay. Okay. Alles, it works. I will make now next words. Microsoft. Microsoft. You see, what is it? Microsoft Max Solver. I will give him this question. Okay. I already explained it. Now, okay, I will give him this equation. Okay, he's ready. Okay, let's see. Ah, are you ready? I think you can do it. Okay, I will erase this no need. Because we put it different things. Okay, this is no need. Come and solve this, please. Hmm. You'll see, this is Microsoft Solver. Complex number, 5 problem similar to it. It did nothing. You see, I told him solve, solve. This what? Solve, solve. He did nothing. Again, I will do it again. Come. He did nothing. So it can be fact, it can do. Okay. This is Microsoft. Okay, the powerful tools. So I have okay. I didn't try. Not a detail. Okay. Okay. Stop it. Microsoft server. Stop. Stop with it. خلاص. He did nothing. خلاص. He did nothing. Okay, look. Here was the equation as I did. Nothing to do. It will be Allah. Okay, this is the Professor Mourad Sultan Ezouidi. So let's see GeoGebra. Not GeoGebra. ChatGPT. ChatGPT. I ChatGPT. Solve this. Look. Solve this. Okay. This is ChatGPT. Okay, that's very interesting and beautiful this way. Okay. Coefficient intellects are we okay. So, okay, continue. I told you solve. Find the exact roots. I will tell him find the exact roots. Can you can you find the exact roots? The exact roots without without approximation. Ap- Approximation. Can I? Can you? Great. Okay. Okay. We will proceed step by step. We will try to factorize. Okay. Go. Okay. Go. Some complex numbers. Okay. X means 3. Okay, continue. Let's see. Okay. He did nothing. Let's continue. He entered this absolute approximation. Hmm. He found 3 minus 3 minus 2. No false. Okay, there is no false. No, no false. No false. He will try again. Okay. So it's not easy, in fact, without using multimeter. Okay. So thank you for listening. This is more sometimes really okay with you, was with you, and we will be always with you. Goodbye and salam alaikum. So thank you for listening. This is Mourad Sultan Ezouidi. Okay. As we told before, let's dive into the structure of Mr. Sultan Ezouidi, and we can see that every time speaks, every quote has a message, and it's really method knows how to listen. Okay. What seems impossible by tradition becomes true and exactly this method. Thank you for listening. And else, and we can say that we have the image, and I will work your class 8 day after day. Allah. Thank you and goodbye.